Hey Jeff, here's a update summary on the changes to the gINT rule for the N60 calculation. So here we are on the sample table. As you can see, we have our raw data entered. N60 hasn't been calculated yet. We do have these two fields where there's some manually hand-entered data. Come back to those later on. But as we discussed, we changed it so that in the project table, the user will have to enable the calculation. So they'll have to calculate or check the calculate N60 box. So I'll do that now. Just a reminder that the gINT rule is triggered by a save in the sample table. So we don't have a save right now. So the N60 hasn't been calculated yet. But if we go into gINT rules, recalculate current table, we could also force the calculation that way. So here we are. Here's our values calculated. So how this works, the first thing I want to point out is that the first thing the code looks at is to make sure that the sample type is SPT and a hammer correction factor is entered. If those two values are not entered, then it's just going to skip that row. I'll kind of come back to that later on. But once it sees that you have SPT as a sample type and a hammer correction factor entered, then it kind of looks at the rest of your data and figures out how it's going to handle whatever scenario it is for that sample. So here at the top, a couple samples, we see the normal scenario. So of course, SPT and hammer correction factor are entered. Your length is 1.5, meaning it's a full penetration. And you have all your blow counts entered. So in that case, it just calculates N60 straightforward. Then we get down here, we see full penetration again, and the blows second, blows third are both 0 for both these cases. Doesn't really matter what blows first is. And then you get WOH, weight of hammer, is your N60. Let's see here. This one is just a normal one, like the top ones. And here we get to some refusal scenarios. So basically, again, it needs to see the SPT type and hammer correction factor. If one of those is missing, again, it's just going to skip it and it won't do any calculation, even for a refusal. But then if it sees that the sample length is less than 1.5, then it's going to know that there was some sort of refusal. It also needs to have a blows first entered at least to report refusal. And the reason for that is that with your legacy projects with the old data template, there would not be blows first entered. So that's just kind of one level of protection to not overwrite what might have been manually entered in those legacy projects. So if there's no blows first and it's a refusal, so less than 1.5, it's just going to skip that row and leave whatever is in there. Same thing, again, that's the reason why the hammer correction factor is always checked, because for those legacy projects, it's not going to be entered. So that again is another level of security for any test, just to not do the calculation if there's no hammer correction factor. It's again security for legacy data. So anyway, it's pretty straightforward then. If those conditions are met, it'll report refusal as just REF at whatever the sample length is. Okay, so here's kind of what I've been talking about for a legacy project. We had a hand-entered value in the past. We converted it to the new data template with the gINT rules, and you don't have your blows, you don't have a hammer correction factor, so it's just going to keep whatever is entered there. again here, showing once again how that hammer correction factor comes into play. We have everything else entered. We have SBT, we have full penetration, we have all three of our blows, but that calculation did not overwrite what we had in there. So, that can be used kind of as a crude way to prevent the automatic calculation. So let's say here 017 automatically calculated 11. For some reason we want to put just a random value in there, so I'll put random value. But of course, when I save, it's going to overwrite it. So what I will do here is I'll just delete that hammer correction factor, write random value, and it will keep it there. So that's, I know, it's a little bit crude, but it does a job. You probably want to put like maybe a little notes field in here if there isn't one already, and just say a hammer correction factor intentionally left off, wanted to overwrite this value, just a little note there so someone else doesn't come in and type it in. I don't think that's something you're gonna commonly take advantage of or need, because it's a pretty simple calculation and kind of covers all your different scenarios. So whatever automatically calculates should be valid, but you never know, and that gives you kind of a little bit of control if there's just one case where you want something different in there. But I'll go back to the way it is normally, and then it's calculated. So, and then this last example here, of course, is just if it's not an SBT, here we have a Shelby tube, it's not going to do the calculation. So even though everything else is entered, it's not going to do the calculation, obviously. All right, so then the only other change I made other than that is for the report. So now we want to make sure that in the N60 on the report that these values don't show up. So I just tweaked the USD a little bit so that there's this is numeric function. So it's only going to show what's in the sample.n60 field if it's a numeric value. That really only comes into play for way to hammer, or if you had some legacy data where it was something was hand entered and it wasn't numeric, then it wouldn't show it. But refusals normally shouldn't be shown, and it should normally just show the numeric values. So that's about it. Let me know if there's any questions or anything that needs to be different. Thanks.